All right, so here you are given a graph, and we talked about this at the end of last class. It said that the graph of this function consists of a semicircle, 3 line segments, and g is the function given by g of x is equal to the integral from -3 to x of f of t dt. So before we concluded class, you guys told me that if this is sitting on the right side of the integral, this is a derivative, true? Okay, so that means this graph is a derivative, correct? Okay, so this is not an original function. All right, so what we need to think about is this table that we talked about, and then how it relates to some of these questions that were given here. So in part A, the question says, find g of 0. So if we want g of 0, I'm going to go to this table right here. What do I literally have to do? Finding g of something.
Plug into the x.
Plug into the x on the integral. Yes. I literally want to find the area under the curve. So this is saying the integral from -3 to 0 of f of t dt. Okay, I don't know what f of t is. I don't know what the function is. So I actually have to go to the graph, and I want to go from -3 to 0. Okay, so if I go like this, I now have a rectangle and a triangle. Okay, what's the area of the rectangle? That would be, it is 3. Plus, what is the area of the triangle? It's 1/2 the base times the height. 3/2. Okay, yeah. So then when I calculate the area, this is what, 6/2, what is this, 9/2? So g of 0 is 9/2 or 4.5 or 4.5, however you get, it's all the same thing, right? Okay, and then they ask us for g prime of 0. So then when I go back to this table, g prime, what do? It's going to be the point. So what am I looking at on the graph to find g prime of 0? F of 0, which is what? 1. You're done. Okay, now that table will not be given to you. We gave it to you in your notes. You need to remember that. Okay, it's there for you to help you interpret all this information. So let's take a look at part B. Find all values on the open interval from -5 to 4 where g attains a relative maximum, and then justify your answer. Okay, we kind of talked about this already. So on the open interval from -5 to 4, where g attains a relative maximum. So this is a derivative, right? This graph. So what are we looking for if we're looking for a maximum? Increasing to decreasing. Okay, meaning where the graph goes from above to below. Okay, where does that happen? Anywhere? At x equals 3, right here. That's the only place that happens. So we would say that g attains, and I'm just using the wording from the question, a relative max at x equals 3 because this is where f of t goes from above to below the x-axis. Explain how you came to that conclusion. That's exactly what we just did. So just like in English, you have to sort of restate the question in your answer. Here, I'm stating what I'm giving, and this is why. That's the justification. What do we want to avoid? A lot of people did not avoid that on the quiz, just saying. We used it a lot. Need to avoid the word it. Okay, I'm not saying in general, just in the beginning of a sentence. It attains, what is it? bunny rabbits, cars. You have to be specific, okay? All right, part C. Oh. Find the absolute minimum value of G on the closed interval from -5 to 4 and justify your answer. Absolute. What is the process in finding an absolute max or an absolute min? Yeah, I'm going to have to do essentially a truth table. It's going to be a little bit different here. But for the truth table, how do I use or how do I find values to use?
Plug into the...
Okay, I really don't have a function, do I?
No, you don't.
Okay, so I'm going to have to use the graph, but how do I know what my points are that I'm looking at?
Critical numbers.
Okay, how do I find those critical numbers? Of the function. Okay, how do I find the critical numbers? Okay, we are looking for, I'm going to go back to the question, absolute minimum. Okay, so I'm going to have to look at the graph. I need to look for the relative minimum, but am I only testing one for absolute? There was a rule for this. My endpoints on the interval, which is why it's closed versus why it's open. Does everyone understand? This was relative, this is absolute. Do you remember that? Okay, which is why we had the truth table, but now our truth table is actually going to be the work in finding the area under the curve. It's okay. So we have critical numbers where x is equal to -5 and 4, but we also need a relative minimum from the graph. How do I find a relative minimum? Below to above, decreasing to increasing. So where's that? -4. Okay, so now I have 3 critical numbers. Technically, I'm doing a truth table, but I have to do the work because in order to figure out what this is, I have to find the area under the curve. So what we're doing is we're going to evaluate G of -5, okay, which means we have the integral from -3 to -5 of f of t dt. What's the first thing you notice about this?
It needs to be a universal spell.
I need to flip it over. Okay, so we have the opposite of the integral from -5 to -3 of f of t dt. Okay, let's go to the graph. So I'm going to go up here to the top. We're going from -5 to -3. Tell me what you see. Triangle, triangle. One above and one below. So tell me about the area under the curve. Ah, it's 0. Okay. So even that flipping, it doesn't make any difference because there is no opposite of 0. It's just 0. Okay? All right. I'm going to do G of -4 first, just because I know what the work is. I'm going to show you G of 4 in just a second. But when I go to G of -4, this is the integral from -3 to -4 of f of t dt, which means we have to flip this, right? So it's the opposite of -4 to -3 of f of t dt. Everybody okay? Why are we flipping? Why are we flipping this? Your values have to go from smallest to big. Yeah, so when you're in the negatives, you have to be really careful. Yep. Yeah, you do. Okay, so let's go up here. We want to go from -4, which is here, to -3. Oh. Okay. Well, this is just a triangle, right? And it's already sectioned off. So it's 1/2 the base times the height. So what's the area here? It is 1, but I have to take the opposite of that. So what's it? Excuse me. What's this answer? -1. Okay. So far we have 2 answers. We need one more. We need to find G of 4. All right. So we're finding the integral from -3 to 4 of f of t dt. All right. First of all, are the bounds okay?
They look bounded.
They look okay, right? I don't need to change anything?
Yeah.
All right. So now what I need to do is take a look at what do I have from -3 to 4. So we're going to go to the top here. I'm going to show you, in this case, splitting the integral. You don't necessarily have to write this, but what's going to happen is we're going to have multiple shapes that we're dealing with. So if we're going from -3 to 4, we're going from here all the way to here. Okay, so take a look. We have from -3 to 0, we've actually calculated that. Then we have this weird situation from 0 to 2, and then take a look at 2 to 4. What can you tell me about the integral from 2 to 4? Okay, it's going to be 0. So I'm going to write down what I'm thinking, what my thought process is. So what we have here is the integral from negative 3 to, what did I say? To 0, thank you, of f of t dt. Thank you so much. Plus the integral from 0 to 2, plus the integral from 2 to 4, which we already figured out. Okay, so now what I'm going to do is I'll be able to write the areas underneath each one. You guys told me that this area was 0 because we have the same triangle above and below, so this is 0. Okay, so that's one less thing that I have to do. If I did it right, I have the answer from negative 3 to 0 if I go up to the top. What is it? It is 9/2. So now the only work I have to do is for this. Okay, so let's go up here and let's take a look. Think about this first as this shape here. Imagine that there is no semicircle. What do you have without the semicircle? Okay, we have a rectangle, so that's easy. It's length times width. What is the area of that rectangle? 2. Okay, so I'm going to, down here below, you don't see it, but I'm writing a 2. Now, imagine that this rectangle is a fish tank, right? And it's got water in it all the way to the top, and I take this ball that only half of it will fit in, exactly half, and I push that ball in there. What happens to the water? Comes out, right? So then what I have here is this area that's left and this area that's left. So how would I calculate what's left? Subtract this, subtract that semicircle, right? Okay. So let's find the area of the semicircle. First of all, the area of a circle is what? Pi r squared? But now we want half, so it's pi over 2 r squared. What's your radius? It is 1, so that's just what? Pi over 2? So we've got 2 minus pi over 2. Half of a circle. Okay. The radius. That's a diameter.
Oh.
Radius.
Oh, I see.
Okay. Yep. Okay. So there we go. This is it. This is non-calculator. I have no calculator. So how do I figure this out? I'm freaking out. Remember, we're looking for absolute minimum. We got this. This is 4.5, right? That's okay. Pi is 3.14. Cut that in half is 1.07. 2 minus 1.07. I don't know the exact value. I could figure it out. All I know is it's positive, right? So this is going to be positive or negative? Positive. Did I find my absolute minimum? I did. It's right there. So you would say that G has an absolute minimum at G of negative 4 is equal to negative 1. Okay. Show my analysis, please. That's all that math. That's my analysis right there. Questions? Okay.
So, why is the boundaries from negative 3 to
Let's deal with the last question here, which says find all values of x in the open interval from negative 5 to 4, which means these cannot be inflection points, at which this graph has an inflection point, or a point of inflection. Okay. Does it ask you to explain your answer or your reasoning or anything? No. It just wants answers. So this is a good, nice, quick, easy one. So first of all, what you have to consider is the graph that you're given is an original or a derivative. Okay, so if I want inflection points, what am I looking at? Second derivative. So how do I find that from the graph? What's another word for derivative? Slope. Okay, so I am looking for what with respect to the slope? Yeah, where the slope changes. Perfect. Okay, so just go from left to right. And I'm going to list them as you tell me what they are. Where does the slope change first? And where? -3. Okay. Where else? Even before 2. Yes. So slope is negative here. Slope of the tangent line is still negative. What happens to the tangent line slope here? Yes. So we've got 1, and then I heard 2. That's it. You do not have to justify your answer. Why? It doesn't ask you to.